Welcome to tonight's video on the dot product. The dot product of two vectors is the sum of the products of their horizontal components and the diagonal components. So basically, if you have two vectors, v and w there, then basically you're going to multiply the a terms together and then add that to the product of the b terms. So for example, here, I'm going to go 5 times negative 3 plus negative 2 times 4, and that'll give me v dot w. So negative 15 plus negative 8 gives me negative 23. Or I can do the reverse, v dot or w dot v. So I go negative 3 times 5 plus 4 times negative 2. And notice negative 15 plus negative 8 gives you negative 23. So the order that you do the dot product in does not matter. V dot w or w dot v, they're going to be equal. When you multiply a vector, when you take the dot product of a vector and itself, so you'll multiply the two I components together, and then add it to the product of the two j's. So 5 times 5 is 25, plus 4 is equal to 29. Now, if you notice something about that, if I took the magnitude of v, so I take 5 squared plus negative 2 squared, notice I get 25 plus 4, which is the square root of 29. So notice v dot v is equal to the magnitude of v squared, because if you square the square root of 29, you get 29. So two properties we learned about dot products here, that if you take the dot product of its own vector of itself, you get it equal to the magnitude square, and that the dot product is commutative, that w dot v is equal to v dot w. So here's another example. So here we go 7 times 2 plus 4 times negative 1. So we get 14 plus negative 4, which is 10. And since it's just the reverse order, it's also going to equal 10. And then w dot w, well, that's 2 times 2 plus negative 1 times negative 1. So that's 4 plus 1, which is 5. All right, so on the next page, we have some properties of the dot product, and these are two that we talked about, number 1 and number 4. Anytime we multiply a vector by 0, take the dot product of a vector and 0, it's equal to 0. And also the dot product is distributive, meaning I can distribute this in and take the dot product. And also it's associative, which means I can reassociate the parentheses here. Those are the products of the dot product. The angle between two vectors is given by the cosine theta equals v dot w over the product of the two magnitudes. If you look on page 787 of your textbook, there's a proof of the angle between two vectors and how they get this formula and using the law of cosines. I'll do it in class, but for the purpose of the video and time, I'm not going to do the proof on the video. So if I'm finding the angle between the two vectors, and what this means is basically if you have two vectors, 4i and negative 3j, so here's 4i minus 3j, and that's vector v, and then I have vector w of I plus 2j. Basically, what you're trying to do is find the angle between these two vectors, and that's what we'll call theta. Theta is the angle between the two vectors. So what you need to know first is what is v dot w? And it is 4 times 1 plus -3 times 2. So it's going to be -2. Then you need to know what the magnitude of v is. So it's going to be the square root of 4 squared plus -3 squared. So it's the square root of 16 plus 9, which is 5. And the magnitude of w, which is 1 squared plus 2 squared. So 1 plus 4 gives you rad 5. So then the cosine of theta is equal to -2 over 5 rad 5. So that means theta is equal to cosine inverse of -2 over 5 rad 5. And when you type that in your calculator, you get 100.3 degrees. All right, so let's try the next one. So here we got to find the dot product, v dot w. So it's 3 times -1 plus -2 times 4. So -3 plus -8 is -11. The magnitude of v, it's the square root of 3 squared plus -2 squared. So 9 plus 4 is 13. And the magnitude of w is -1 squared plus 4 squared. So it's the square root of 17. So theta is going to equal the cosine inverse of -11 over the square root of 13 times the square root of 17. And when you type that in your calculator, you get that theta is equal to 137.7 degrees. All right. So then, to prove that two vectors are orthogonal. Orthogonal is another word for perpendicular. If the dot product is 0, then they are orthogonal. So for example, if I ask, are these orthogonal, and I take the dot product of v dot w, 6 times 1 plus -3 times 2, notice I get 6 plus -6, which is 0. And the answer is yes, v and w are orthogonal. Since the dot product is equal to 0. So here, v dot w is equal to 2 times 6 plus 3 times -4. So it's 12 plus -12, which is 0. So once again, yes, v and w are orthogonal, meaning they're perpendicular. Two vectors are parallel if one vector is a scalar multiple of the other. So if you notice here, w is equal to 2 times v, because if I go 2 times 3i minus 5j, notice you get 6i minus 10j. So since v is a scalar multiple of w, v and w are parallel. All right. So to find work, the application of the dot product, the work done by a force moving on object from A to B is the magnitude of the force times the magnitude of going from A to B, basically the distance, times the cosine of theta. So if a child pulls a sled along level ground exerting a force of 30 pounds on a rope that makes an angle of 35 degrees, how much work is being done to pull the sled 200 feet. Well, the magnitude of the force is 30 pounds. The magnitude from A to B is 200 feet. That's how far you're pulling it. So the work is equal to 30 times 200 times cosine 35. And when you type that in your calculator, you get 4,914.9. So basically, we'll make it 4,915 foot-pounds, meaning basically that's how many pounds per feet you're exerting. All right, so the next one, a child pulls the wagon along level ground, exerting a force of 20 pounds. That makes an angle of 30 degrees with the horizontal. How much work is being done by pulling the wagon 150 feet? So then the cosine 30, so you calculate that, and you get 2,598 foot-pounds. All right, that concludes tonight's video. I hope you enjoyed it, and I hope you have a good evening. See you in class.